Hey guys, HackerSploit here, back again with another video. Welcome to the all-new Penetration Testing or Pentesting Diaries series. Pentesting Diaries is a new weekly series where I will be exploring various pen testing techniques and tools and some of the latest attacks that we're seeing in the cybersecurity industry today. Now, the primary objective of this series is to demystify these pen testing techniques and tools that, again, you may or may not be familiar with. And we're going to be doing this in order to provide you with a deeper, more holistic understanding of how specific attack techniques work, what tools to use, when to use specific tools, and more importantly, how to correctly use tools to optimize your efficiency and consequently your proficiency as a penetration tester. Now, in addition to that, I'll also be using this video series as a way to share my own personal knowledge and experience from my escapades as a penetration tester. So, I'll be using it to give you a realistic view of what pen testing is like through some very, very cool practical labs, and I'll be touching on that shortly in this video, so really excited. So again, primary objective, give you a realistic view of what it takes to be a proficient penetration tester. Now, for this series and all other videos on the channel moving forward, these videos will be underpinned by an augmented form of cybersecurity training, and this is what I had alluded to in my channel update video. And the objective here is to give you a new or an improved form of cybersecurity training where you can pretty much do what I'm doing in these videos in a matter of minutes in your browser, without having to set up your own environment, and that will sort of bridge the gap that I was having challenges with. As and when I wanted to, dive into more complex topics or techniques. So I'll be touching on this in a few seconds as I introduce you to, the tool or platform we'll be using. So really excited for that. With that being said, welcome to the first episode of Pentesting Diaries. And in this series, or in this particular episode, we're going to be taking a look at SQL injection. And the objectives or the outcomes will become clear as we progress. But hopefully you enjoy this series. Let me know again once you've watched the complete episode or the video. Let me know what you think, and I would like for you to share some recommendations for future episodes or topics that you'd like me to dive into. But as I said, just as a final word, this is going to be a weekly series, and it's going to be made or built up by you guys and your recommendations on stuff you want to see. With that being said, let's get started with today's episode of Pentesting Diaries, and I'll see you in a few seconds. Alright, so welcome back everyone, and before we get started with SQL injection and what the scope of this video is going to be like, or this episode, I want to introduce you to the platform we're going to be using, or I should say you're going to be using, to again follow along with not just this video but other videos on the channel. And that platform is CyberRanges. Now again, I'll introduce you to CyberRanges, and I'll explain why CyberRanges, or why I use CyberRanges for a lot of not only my own training, but why I think it'll be a very useful tool for you in making that next step, to becoming a professional or a seasoned professional. So what is CyberRanges? Well, if you're not familiar with what a CyberRange is sort of a more advanced version of some of the online platforms, the online virtual lab platforms that you see, like Hack the Box or Try Hack Me. And when I say they're a bit more realistic and complex, that's inbuilt. So the objective of a CyberRange is to provide you, whether you're a pen tester or a SOC analyst, with an experiential experience, or with experiential knowledge, skills and abilities, that you require in order to operate proficiently within a particular role or career path in cybersecurity. So the difference, as I said, the reason why I'm using CyberRangers is firstly the ability to create and share with you guys my own labs, which allows me to provide you with, pretty much the exact experience as what you're going to be seeing in these videos. But more importantly, dive into deeper, more advanced topics like, for example, AD penetration testing, purple teaming, so on and so forth. But with that being said, the link to CyberRangers is in the description section. The URL is just app.cyberrangers.com. And again, don't worry, you're not going to need to pay anything. It's going to be absolutely free, the lab we're going to be using. But you can create an account if you don't have one already. So, just click on register, and you'll need to provide a unique username and a functional or valid email address, because you will receive a confirmation email. That'll then take you to the next step of activating your account, which just involves setting your password. So you don't set your password here. You can leave the promo code section empty, and of course you can go through the terms and conditions. So I know you're probably wondering, what does it look like and how does it work? Well, I'm just going to log in with my account, and there we are. So this is the CyberRangers platform. Now you're going to see a lot of labs displayed here, and the section that again I'm going to be using in this video, or the lab I'm going to be using, is available under the free section. And you can see this here, and so for example, this set of labs here is the MITRE ATT&CK Defender Adversary Emulation labs. We're actually going to be using these for the adversary emulation sub-series, part of the larger red teaming series on the channel. But these were labs that I built, and again, we'll be going through it. But yeah, these are pretty much the free labs you can go through. For the purpose of this video, we're going to be using from SQL injection to shell. So this is an adaptation of the Pentester labs, I believe, lab on the same topic, which again, I'm going to be using to demonstrate or to, demystify SQL injection. And I'm going to be explaining a lot of things. So there's, various other ones that you can go through in the free section. For example, there's multiple vuln VMs or boxes that have been imported here. Again, credit going to the authors of them, and these are available for free. But the really cool thing, and this is what I was referring to, is for example, if I can go in here and click on that one, I'm just going to start it. The great thing about CyberRangers is obviously the control of the environment you'll be provided with. Now, this is not a complex environment because, we only have two systems, and that's what I was alluding to. So you can pretty much use or go through these labs directly from your browser with your own dedicated Kali Linux system without VPN. Now, you do have the option to again connect via VPN if you're using your own Kali Linux system. But pretty much for all of the attack or offensive scenarios, and the scenario is just a lab in the CyberRangers parlance. So, you'll be provided with a Kali Linux system, and the target web server IP will be provided here. So the lab shouldn't take more than a couple of seconds to a minute to start up. So I'm just going to wait for the lab or for my lab to start up, and we can then move on. So I'll see you in a couple of seconds. All right, so once the lab is good to go, you can just click on start right over here, and it'll take you to the lab page. So given the simplicity of this particular lab, in terms of the objectives, you can click on your service tab where you have your dedicated breach box or attack box, as it were. And CyberRangers is called a breach box, which is essentially, a Kali Linux system that again is dedicated to your session. And you can pretty much just click on the drop down on the services here. And one thing is the IP annotated here is the IP address of the system within the private VPN network. So if I just click on the service here, this will give you RDP access to the Kali Linux system from within your browser. as you'll see, or as you can see here. And there we go. So just give it a few seconds. I don't want to authenticate, but there we are. You have a fully fledged Kali Linux system that's dedicated to you, so there's no sharing, and it starts up with the lab, so you don't have to start it up separately. And secondly, the network is segmented, and one of the things you'll see is consistency with the IP addresses. But the bottom line is you then have your target web server, which is what we're going to be targeting. And you can also view the web server that's running on the target web server within your browser, so not within the Kali Linux system. So there we are. You can actually see on that web server. So if you want to use your own Kali Linux system and use the proxied URL here, you can. If you want to use the Kali Linux system that's been provided to you, you can do that as well. Again, it's fully configured and good to go. So again, we can pretty much start off from this point. So that is, of course, navigation on the CyberAngels platform. If you want to connect via VPN, you can just click on the top right here on the VPN icon, and you can either download the CyberAngels VPN client, which is a GUI application for any operating systems, Mac, Windows, Ubuntu, very different variants or different Linux distributions. Or you can download your OpenVPN certificate, so 2.4, 2.5, and connect as you would, if you're using any other platform, and you then use your own Kali Linux system. So it's up to you. In my case, I'll just be using this here. And yeah, so now that we know how to navigate around the CyberAngels platform, we're now going to be taking a look at our objective, which is, SQL injection. And as you can see, based on the title of the lab, using SQL injection or leveraging a SQL injection vulnerability to gain a shell on the underlying server. So there we are. So I'm just going to switch over, and we can get started with this episode of Pentesting Diaries. All right, so we can finally get started with SQL injection. So I do apologize for the long intro, but as you're expecting, the first thing that I'm going to explain to you is, what is SQL injection or SQL injection, and what is SQL injection? Well, SQL injection can be seen as a subcategory of attacks or vulnerabilities that fall under code injection. So what is SQL injection all about? Well, SQL injection is an injection, more specifically a code injection technique that is used to exploit vulnerabilities in web applications by injecting malicious, they don't need to be malicious, but malicious SQL statements. So that's the first point. SQL. What is SQL? SQL is the structured query language. Now, given that we're dealing with a structured query language, and I'm sure you're already aware of this, one of the prerequisites for this attack working, or for you to even consider testing for SQL injection vulnerabilities, is that the web application or the website that, again, you may be performing a pen test on needs to or requires pretty much as a requirement, to essentially be using a relational database in some form. Now, relational databases, some examples of these are MySQL, PostgreSQL, etc., etc. I can go on and on. I do know there are NoSQL databases. That's another exciting idea for another episode of Pentesting Diaries. But what you're trying to do is you're trying to look at a web application and analyze input, web application inputs or areas within the web application where you can input data. So you can think of, the common examples: a login form, right? A registration form, URL parameters. If you take a look at the HTTP request, whether it's, get or post, you have various options in there that you can try and inject the SQL queries into. But generally speaking, that's the starting point. So firstly, you need to have a website that, again, is using a relational database management system, or RDBMS. Some common examples I've already given you. Secondly, you need to identify or start identifying areas within the application where you can input these SQL statements. And what you're trying to do is moving on or proceeding on from that, you're trying to find web applications that are not filtering these SQL statements wherever you're inputting them, whether it's a login form, the URL parameters, etc., etc. And in terms of weaponization of this technique, it's fairly, I think most of you are already familiar with it. SQL injection essentially allows attackers to view, modify, or delete database data or records, and even gain administrative access to the database or the underlying server that's hosting it. So we'll talk a little bit about the types of SQL injection vulnerabilities, but I just wanted to get that out before we get started. So that'll also give you an idea as to the methodology that you can start forming. So in this particular lab, we have the target web server. It's running on 192.168.125.150. So I'll open up the Kali Linux system here, and let's do what we usually do. Let's perform an nmap scan. So I'm going to say nmap, and we can perform a SYN scan here, service version detection scan, and let's perform a fast scan, which will only scan 100 of the most commonly used ports, and then 192.168.125. If I can type that in, 0.150. All right, so there we go. Yep. Look at me, silly me. We need root privileges. By the way, the passwords for the Kali Linux system, or the password, I should say, is listed here. So it's just Kali and password. So I'll just type in password. Fairly simple. There we are. All right. So objective here, starting off with your basic port scanning, trying to see what services are running or what, ports are open on the target web server. What services are running on those open ports, and then commencing with our enumeration or information gathering, if you will. So there we are. We can see that this is definitely a Linux server, and we have an SSH port open, running OpenSSH 5.5p1, and we have a web server running on port 80. So no SSL cert. That's Apache HTTPD 2.2.16. Now, one thing I would like to correct in your methodology, and especially if you're a beginner, if you've been watching CTF videos, or you've been using CTFs to practice, because of how CTFs are designed, your first inclination might be to try and search for vulnerabilities related to the service that's running, whatever it may be. In this case, it could be Apache. Now, what you'll typically see is, someone running SearchSploit or trying to search on Google for vulnerabilities related to that version of Apache. So I would not recommend doing that, or that's something that, again, I see a lot of people wasting time with. Now, again, I'm not challenging your methodology, but first thing I like doing is, let's just see what's running on the web server, or, and so I'll say 192.168.125.150. Let's just see what's going on. All right. And I would always recommend, especially when performing a web app pen test, to approach it, as you begin, approach the web application as a normal user would. Don't, again, try and make it too complicated, and just try and see, how this works. Now, what I'm going to do here is, I just put in, I just put myself in full screen here. Let me just adjust that. Give me a moment. All right, that's much better. But as you can see, this is a fairly basic website. It looks like an awesome photo blog. All right, this looks very interesting. This looks like an image itself. Ironic. So the last picture is Cthulhu, with not a very good image or representation of Cthulhu. For those of you who know about Cthulhu, let me know in the comments. So we also have a menu of sorts, very rudimentary. So home, we click on that. And what I'm analyzing is the URL here to see if any parameters are being passed, especially when dealing with, content management system, or anything of the sort. So we then have a test page, and okay, so the test page, we have what appears to be two images that have been posted on this photo blog. So Ruby, Hacker, and Cthulhu. Okay, interesting. We have Ruxcon, and I know you're seeing what I'm seeing. So we have a picture of a hacker 2010, nothing in there. Pay attention very closely to what exactly is transpiring here. You then have all pictures, which lists all. Nothing interesting in this case, but still something worth exploring. And I want you to pay attention very closely to, these errors. May not really be related to what we're doing, but just good to see what's going on. And then, of course, we have a login page. So, you again may be very tempted to start running SQL injection payloads, and that's what I'm trying to correct here. So before we even do anything, we can take various approaches from this point. You may want to perform a directory brute force to see if there's any hidden directories, etc. And again, I'm just going to be going through what I typically would do when I've seen interesting stuff like this here. And there's a reason for that. So the starting point I'm going to use is the URL itself, because this is very, very, very important. So I'm just going to, put it into mousepad here, and let me increase the font size so you can actually see this, and I'll explain why I'm doing this. So we have a URL. Let me explain a couple of things. So this section, we obviously know the protocol, that's fine, but this could either be a domain name, or an IP address, really doesn't matter. But this section here and this one right over here, this represents or specifies, as you know, the domain or IP and the resource that's being accessed on the server. The resource being the file, right? So the file we're accessing is PHP. And in order for PHP to be executed, you need to configure PHP on the underlying server, and obviously the web server that supports PHP. But then what comes after it? And you'll typically see this with PHP-based web apps. You have a question mark, and then, it could be ID or pretty much any other word in this case, and that's equal to 1. So this is the penultimate example of SQL injection used to, again, teach SQL injection, but we still need to dive a little bit deeper in here. So whenever you're dealing with URLs, and I know I'm explaining the structure of URLs here, we have the resource, and this resource is a PHP resource. And in this particular case, what is ID and why is ID equal to 1? Or what does that mean? Just again, in the context of the functionality of the web application. So the this collection here, or this these two values, I'll not call them values right now, are what you refer to as the query string parameter, where ID is the parameter or the parameter name, and 1 in this case is the value. So what is essentially going on is that this script or this resource, which is a PHP resource, looks like it requires a certain parameter and a value to be specified in order for it to do something. Now, what is it doing in the web application? It looks like it's displaying images here. Now, again, we're not going to dive into the functionality of how this web app was programmed or developed, but that's what that means. And the reason this is important is because, again, going back to my earlier explanation when I was referring to what you need to check for before you start testing for SQL injection vulnerabilities, what you need to check for is whether, and this can be a bit difficult, but it's fairly easy, you need to identify whether the web application is using a relational database, regardless of the type, whether it's MySQL or PostgreSQL. And one of the ways this tells us that there is a relational database being used by this web app is because the ID parameter, and again, you'll see that is very common with PHP, but the ID parameter is commonly used to reference a specific record, and I'm sure you're aware of what records are in the context of databases. So it can be used to reference a specific record or item or row in a database. And again, not always the case, but for the sake of this example, because the value of the ID parameter is numerical, there's a very high possibility And again, in this case, we don't know what it's referring to, but there's a very high possibility that the ID or the value of the ID parameter represents within the relational database, it represents the unique identifier. Now, unique identifier of what? We don't know, probably images, but ID equals 1 displayed 2 images, so that might not be entirely clear. So we can proceed with a bit of testing, but in this case, it looks like the ID parameter is used to specify a specific page or display a specific image, and these pages or images are uniquely identified by the numerical value here. Now, you may also see other instances where the value of ID or whatever parameter can be in text format, and that's very important because, again, you can also fetch data from a database, with PHP using, using whatever attribute of a particular entry or record in a database. The point I'm making is this is arguably the simplest to understand. So, all right, I've rambled for long enough. I'm pretty sure you know what to do. But the first thing you might be tempted to do is to see, what this does. So if I say, for example, change the ID to 3, we can see it doesn't display anything. So it's most likely pointing to blog posts that, again, in this case, just display images. So if I go to 4, you get the idea. Doesn't look like we have any entries. If I say 100, same thing. You get the idea. Now, when testing for SQL injection, and I know the rudimentary, I know that this particular example is rudimentary. When testing, many people, again, may be tempted to go directly to the admin or login form and test it out there and start running payloads from GitHub. But the first thing you want to do is run a few tests to see whether there is a database, whether queries are being sent, and more importantly, whether the queries that you are sending, that you're injecting into the value of the parameter are being filtered or sanitized by the back end of the web application before being sent to the database to be executed. So the way web applications work in the context of databases is when I hit, or when I run this GET request, so I just hit enter, we're essentially asking the backend PHP to reach out or to communicate with the database and fetch the data associated with this identifier. In this case, I'm pretty sure it's an identifier, right, of a particular record. Now, it's important to note that in properly developed web applications, this identifier here, or this, this type of request that, again, allows for specification of an identifier or data that's going to be, again, sent to the database, the relational database in the back end, this needs to be sanitized or filtered in order to prevent, guys like me or guys like you from injecting very weird things in here. Because remember, if it's not filtered, what PHP does in the back end is it says, okay, this is the request. We need to connect to the database. There's always a config file that contains information on how to interact with the database, how to connect to it. So if it's a remote database, you're going to have the IP address there. If it's localhost, that's fine, the credentials, and it's pretty much going to execute an SQL query that selects a particular record or information from a particular record from a particular table in a particular database. And depending on, how the web application is built and, what the page does, it's going to do something to that data. So it can either display back the data or, if you're logging in, what the query is essentially checking whether the user exists and the password matches. In this case, it's clear that what is happening is the web application, in the backend sends the SQL query, to fetch, and what's sent back is an image, right? And that's what's displayed. So given that this is how this web application is working, and that, it's, the output of the query from the relational database in the back end is displayed on the page to a certain extent, we can start using the infamous single quote, where we would specify the value, and I'll explain what that does. And what we're trying to do here is to see whether errors from the relational database in the back end, the errors are actually being printed out, or again, PHP is essentially printing them out for us, which again should not be done. So I'll hit enter, and there we are. So just by doing that, I'm able to firstly, confirm that we do have a relational database being used, or there is a relational database being used by this web application. And secondly, what we've just done here is error-based SQL injection. Now I'll explain these types as we proceed. And again, you may be wondering why I'm ranting and rambling here, but it'll all make sense. So this is an SQL error, right? So you can see it says you have an error in your SQL syntax. Check the manual that corresponds to your MySQL Server version for the right syntax to use near the quote here at line 1. So what this is telling you, and again, the web application is been built poorly because it doesn't know how to handle errors. There's no error handling, and it's just, the error is just printed out back to the user or reflected back. So this is, again, as I said, known as error-based SQL injection. And in this case, it's confirming that, that the value of the parameter ID is where, we can perform the injection from. It's just one input we can perform the injection from, and it doesn't look like there's any filtering being done by the PHP web application in terms of sanitizing special characters like single quotes, right? And that's typically what web application firewalls do. They filter these, well-known attack payloads or special characters, regardless, as to whether there's URL encoding or not. But so that then begs the question, and again, this is the final thing I'll be explaining theoretically before we proceed. That begs the question, what exactly is the single quote doing? Now, I'll explain this towards the end of the video, and I'll explain why that is the case, or why I'm going to do that. And that's because we need to take a look at an SQL query. But in essence, what that does, specifying a single quote in a URL parameter, as we've just done here, as you've been able to see, often results in an error due to the way SQL queries are constructed and interpreted by the database. So again, I'll explain what this looks like from, the perspective of the SQL query, and why, why the SQL, why the relational database is actually processing this here. And in essence, what you're doing, or what this does, is it pretty much terminates or delimits the string literal. So what you're doing is sort of like in a Linux command, you're adding or appending another command to a command. So for example, if I would to say who am I, the single quote in the context of SQL, or the structured query language, is a delimiter. So as you know, if I run that displays that, but I can also use operators like the AND operator, and then, provide another command after that. And what the single quote does is it's essentially terminating the string literal for the preceding SQL query, and then running whatever you specify after. So this is where you now specify your SQL query that, again, if you're an attacker, can either be used to fetch the tables within the database, extract information, so on and so forth. So hopefully that makes sense. As I said, we'll revisit this in a few seconds. All right, so now that we know that the target web application is indeed running a relational database, in this case it's MySQL most likely, and we've verified that the web application is vulnerable to SQL injection through the URL parameter, that being one example. What can we do? Well, now I'm going to walk you through, the typical technique that you'll see. So you can go ahead and, search for SQL injection payloads on GitHub, or look for cheat sheets and look for, various POC payloads that allow you to verify that this is the case. But this is where, we have the use of the tool SQL map or SQL map, depending on how you want to pronounce it. And what I'm going to do here is I am just going to disable the transparency here because I don't want to see what's behind this. So there we are. That's much better. So I'll now zoom in. And as you already know, you may have used SQL map before, but you hit enter. It's pretty much, the go-to tool for performing or automating SQL injection, and more importantly, weaponizing the vulnerability, the SQL injection vulnerability you've identified, to then do things that, an attacker would want to do, like extract data, list data, just view data, delete data from a database, or, particular tables, etc. Now, there's a couple of, you may be confused in the beginning, on what exactly to do. But the way SQL map works, or the way it tells you you should use it, is to provide the URL of the web application you want to test, but also include the resource, the parameter, and the value that you'd like SQL map to perform the injection on. Okay. So for example, if I just ran the default, SQL map U for URL, and we know, I'll just copy the URL here, and we'll just say this is ID equals to 1, not 100. We can leave it as 100, but there we are. So I'll just copy this. This is what we want to test. We've already confirmed that ID is vulnerable to injection. There's no sanitization. So you typically, this is your starting point. You just specify that, no other additional options, and that's fine. Let's see what SQL map gives us. So SQL map is going to throw out a lot of info, and it's important that you understand what SQL map is telling you. And again, I'll cover the manual techniques after, but there's something very important here. So you can see at the breakpoint here, it says testing for SQL injection on get parameter ID. So get, this is a get request, it's obvious. The parameter is called ID, so that is correct. And then it says it looks like the backend DBMS, database management system, is MySQL. Do you want to skip test payloads specific for other DBMSs? And this is very important because in other relational database management systems, while they all use the structured query language to, again, get data, delete data, add a new record, a lot of these RDBMSs like MySQL, PostgreSQL, Oracle have their own specific payloads just based on how they work. And this is not related to the queries themselves, but more so just the actual RDBMS itself. So for example, enumerating the version info on MySQL, or enumerating the version of MySQL is very different in terms of the commands you type than what you do on an Oracle, on an Oracle database. So we'll just hit yes, and this is the primary advantage that you get with SQL map. But you can see for the remaining tests, you want to include all tests for MySQL extending provided level 1 and risk 1 values. So what this is asking, or what SQL map is asking, is do you want to run all tests? Now, what all tests means is testing for various types of SQL injection vulnerabilities. Now, as I said, I'll explain these because it's not. It's very important that you understand, or you pretty much go through this empirically before you get into the theoretical aspect. But I just explained one of those tests to you, which is, or SQL injection types, which is error-based SQL injection. Now, there's, the other ones that you typically expect, like union-based SQL injection, which essentially involves using or leveraging the union operator to combine results from two or more SQL statements You also have, a second category of SQL injection vulnerabilities, which is blind SQL injection. Under blind SQL injection, you're going to have your Boolean-based blind SQL injection and time-based blind SQL injection, which are arguably two of the most common types of SQL injection vulnerabilities seen in real-world web applications today. So blind SQL injection is slightly different in terms of how it works and how, how exploiting the vulnerability works. So in blind SQL injection, and again, I'm just doing this to clarify it, what you're going to do is send a payload or a malicious SQL query that is either, this is where you have the nuances of using Booleans or Boolean-based queries or time-based queries. But what you're doing is you're not monitoring the output. So as we did with error, we put in a single quote and we're able to see the output of that query. With blind, most web applications will not throw back an error, especially if it's coming from a database. So how do you know if, if the web application is indeed vulnerable or that input is indeed vulnerable? And secondly, how do you know whether your query that you've injected is actually being processed by the backend database management system or relational database? So in blind SQL injection, you're injecting your SQL query wherever the input is, and instead of monitoring the output that is either reflected back on the web page, you're observing the response of the web application in terms of, for example, time. So if you run a standard query, like for example, if we just ran this one here, you can see the first thing would be identifying how long the web application takes to process legitimate requests, and then using a blind SQL injection payload that essentially sends a query that forces the database to wait or sleep for a specified period. And so if the response takes time or pretty much takes longer to load in alignment with the sleep duration you specified, then you know that yes, this input is not being sanitized, and more importantly, the database actually processed that SQL query that contained the sleep command that told the database to sleep, which pretty much made the web application hang. And you're able to verify that, all right, so we know that the web application is vulnerable to SQL injection. So when it asks as to whether you want to run all tests, it's also going to specify you the tell you the level and the risk values, and I'll explain that as we proceed, but I'll hit yes. And what you'll start seeing here is when we hit yes, it's going to start off with the generic inline queries. Inline or in-band SQL injection is the first category. So I mentioned two. We have in-band SQL injection and blind SQL injection. Under in-band SQL injection, we have two techniques. We have error-based SQL injection and union-based SQL injection. Under blind, as I've already explained, we have Boolean-based SQL injection and time-based SQL injection. So when it refers to inline, it's referring to in-band. That's why you have error-based, error-based, error-based here, and also inclusion of union. And let's see if it actually did this here. So there we are. You can see a few union tests there, and you can see it says the get parameter ID is MySQL greater than or equal to 5.0, and error-based we're having order by or group by what's this clause is injectable. And then it's going to test some additional inline ones. So you can see the stacked ones are what you'd consider. Actually, hold on, MySQL inline queries. Here we have stacked queries there. And then you're going to have right over here, we have the time-based one here. So the sleep, and you can see the parameter ID is vulnerable to SQL injection by using time-based blind payloads. And then you can see it's going to do the union tests here, so on and so forth. And for pretty much all of these tests, it looks like the parameter ID is indeed vulnerable. So it tells us, yeah, the get parameter ID is vulnerable. You want to keep testing the others, if any. We're going to hit yes. All right. And there we are. So at the bottom here, this is very important. It's separated using, the separator there, but it says the backend DBMS is MySQL. This is very important information. Don't worry about this error, but you can see unable to connect to the URL, blah, blah, blah. It gives us the web server operating system, Debian 6, the web server, the backend DBMS, and it fetched the data logged or whatever you saw on your screen under the following directory. And yeah, I know my version of SQL map is outdated, but if we just scroll just to this section above that one, you're going to have this section here. So SQL map or SQL map identify the following injection points with a total of 48 HTTP requests. So it ran multiple tests or ran multiple payloads. So just think of SQL map as a tool to automate the testing or use of those SQL injection payloads you typically see on GitHub or on, cheat sheets or whatever. So you can see these are all relevant to the parameter ID using, GET request, because we're not posting. It's not a login form. But you can see Boolean based blind, and then it provides you with the payload that was used. So ID and, as standard with Boolean based SQL injection, what you're doing is you're sending a SQL query to the database and simply appending or using Boolean or a Boolean operation that, again, in most cases will be equal to it. You're using a Boolean operation to, what's the best way of describing or explaining this? To return a different result depending on whether the query returns true or false. So in this case, what we're saying, ID equals 1 and 8,263 is equal to 8,263, which again is going to be equal to true. So we can actually take this payload here and see what that looks like in the context of this web application. So, I'll just paste it in here. ID equals 1. Let me get rid of this duplicate ID there. So we hit enter. And you might be saying, well, what exactly is happening here? I didn't see anything. Well, what we're seeing is exactly what we should be seeing. In that, we know it's injectable. This particular parameter is injectable. We know that the database is processing these queries. And we just provided a Boolean query that is always going to be equal to true. So if true, ID equals 1 is going to be displayed, or that page is going to be displayed. Now, if I say and 8263 is equal to 8264, which is not the case, 8263 is not equal to 8264, what will happen? There we are. So because that is false, it it doesn't display that. So you're essentially combining the initial query, which is getting the page associated with, or that has the identifier of ID 1, and then combining or using a Boolean operation to essentially see whether the application returns a different result. And this is primarily very good for confirming SQL injection, especially when you're dealing with blind SQL injection. And then, of course, we tested error. And in this case, it utilized quite a long payload here. And I think in this case, it displays the version. I might be wrong. Let's actually test it. So ID 1. Let me replace this here. And I know I'm taking time to explain this, but this will make sense. So there we are. You can see this displayed duplicate entry for the group key. Yeah, so error-based just displays an error, which confirms that. And then time-based blind, ID equals 1. And then you can see select 6,999 from select sleep for 5 seconds. And so if this parameter or the web application was vulnerable to SQL injection, and more specifically, let's say it was not displaying any errors, and we wanted to use time-based SQL injection to see whether indeed it was vulnerable, then we would essentially monitor the standard response time when we make a GET request. So PHP ID equals 1. If I reload it, sorry, let me go back here. If I reload it, you can see it's almost instantaneous. And of course, you can monitor this. If I go back, sorry, I don't really use Firefox anymore. Where is it? More tools. Control-Shift-I. My bad. That's quite embarrassing, but there we are. So we take a look at performance here, and just gonna reload this. Let's start that there. Okay, let's reload this here. So there we are. We can see that there, that logged. Let's try it again. Okay, a bit of change there, but yeah, for the most part, and let me stop recording that. You can actually see how long it takes right over here. And, you know, you're trying to see whether there's any deviation in the amount of time. And in this case, we expect this particular query to make the web application, or rather the database, sleep for 5 seconds before returning the result of the query. So copy, and we can now test it out. So actually, let me see. I'm going to we'll actually maintain this here. No, we don't want to toggle that. So let's actually bring this up here. Yeah, so ID, let me replace that. So I will just paste this in here, and that looks okay. Okay, pay attention. Look how long it's taking. So that's what, you know, time-based blind SQL injection is. You're just monitoring whether there's any deviation in the response time by specifying a query, that an SQL query that, you know, tells the SQL database or the backend database to actually sleep or to delay the response, thereby confirming that, you know, that the web application is vulnerable to SQL injection via this input, and, you know, there's no sanitization, and whatever you're sending is actually being processed by the database. So we can actually compare that in the performance monitor here. So I'm now going to start recording here, and just pay attention. So I'll reload, and you'll see that should equate to 5 seconds. Actually longer, but there we are. From the initial request to, let's stop recording this here. So this was, there we are. So we can actually see this to the, yeah, so from this point, I would say, let's just be fair here. And you can see that there. So now actually, hold on. Yeah, that was great to the point when it was returned. And of course, if we just see the call tree here, you can actually see that a bit more clearly. One moment. So idle, there we are. Actually, let me get rid of that there. How do I unbind this? There we go. All right, much better. Yeah, and I can then zoom out. So you get the idea. And of course, let's take a look at the debugger here. Actually, no, let's go into the waterfall view here. There we go. And actually, just to confirm this, we can actually see the time taken, so 5,000 milliseconds. And if we now compare it to the standard query without the time-based payload there, we'll see that speed here. That was nearly instantaneous, 3 milliseconds. Let's go back, and I'll reload this here. There we are. We should see, 5,000 milliseconds, therefore confirming that. So there we are. Anyway, I just want to, this is the stuff that a lot of people skip over, and I wanted to ensure that that is clear. So we also have a union query, which I'll not run. From this point, if this is your first time or you're fairly new to SQL Map, this is where people start getting confused, because SQL Map gives you the payloads it used to verify, that the web application was, or that parameter was indeed vulnerable to SQL injection, and it tells you the types here. But we can actually tell SQL Map to do some stuff for us. So for example, if I wanted to list out the databases, with SQL map. And how would I do that? Well, in order to do that, we use the infamous DBS. So that's double hyphen DBS right over here. Let me just increase the font size and I will clear the screen. And now it will again perform the injection and then utilize specific payloads to extract information. In this case, the information we're telling SQL map to extract is the databases within the MySQL database. So within MySQL, we have the standard information schema database, which is self-explanatory, and one called Photoblog, which I assume is being used by the web application, namely Photoblog. No coincidence there. All right, that's fairly simple to understand. So what if we want to now extract info or view info that's stored in this database? Because databases have tables, right? Well, what can we do now? Well, in this case, we need to tell SQL map or SQL map to do something a little bit different. So we're now going to say use the -D option. This is going to allow us to specify the database that we want to interact with or extract information from. So, if I say the name was Photoblog, if I'm not mistaken, and I just hit enter, and don't worry, I'm doing this for a reason, you can see it doesn't display anything. And that's because, again, if you look at what you just told, SQL map, you just told it, okay, select this database, but you didn't tell it to do anything else. So you need to be very explicit. So one thing you could do is, you could dump all, for example, but there's also, other options that you can use, but let's go with the standard dump all. And I'll use the, we can actually use the batch option here. And don't worry, I'll explain all of this, but let's hit enter now. And dump all, as you probably would have guessed, pretty much does what it says. It dumps everything. So if you can see from where I kicked off, it will display the various tables in the database. And in this case, it started off with what's the name of the table? It's called pictures. And you can see, the web application or the value of the parameter ID was the unique identifier of the record within the table here. So you can see ID would print hacker. You can see cat is 2, so it's referencing another one. So it would also display another image that had the ID of 2, and in this case the ID of 2 corresponds to Ruby. So let's go ahead and open up ID equals 1. You can see that there Ruby and the picture Cthulhu, which is a little bit weird. So there we are. ID cat, so via ID it's actually reversed, my bad. So an ID which is the identifier for the resource cat. So cat takes in an identifier using the parameter ID. It is actually referencing this here. So this column here. So this is what it's referencing. That's why when the value of the parameter ID when using the resource cat.php is 1, it will display Cthulhu. And it'll also display ruby.png. Is that the case? Yes, it is. All right, so we're understanding stuff. If the value of the parameter ID is equal to 2 when using or when loading the resource cat.php, then it'll display hacker.png. So that's one mistake I made when I was explaining this. I thought it was a unique identifier for the actual record or row within a table. So if I say 2, hacker is displayed. All right, so there we are. Anyway, proceeding on, all this information is being saved into the following directories here. And then it's going to fetch columns for the table users, so on and so forth. And yeah, it looks like there's another table called users with only one entry. And in this case, this is obviously the ID is going to be the unique identifier of the record, but we can see the ID, there's only one user, so the identifier will be 1. The name of the username is admin, and the password, the thing has been hashed here, but you know, it's provided in clear text here. So not great password security or hashing practices here. But again, this is typically what you see with, you know, some of those outdated or old websites that constantly are victims of data breaches. They're either using very weak hashing algorithms, or, you know, they're not using salts or password salts. So, you know, we can actually try and log in now. And by the way, the login form could quite possibly be injectable. So if I specify single quote for both, no error, but we can try and log in. So I'll say admin, and I'll paste in the password there, and we log in successfully. And we can actually see the pictures that were posted. So we can actually add a new picture, delete, so on and so forth. So our objective, since our objective was to gain access to the underlying web server, I'm pretty sure you're guessing what I'm guessing. We can upload files. Are there any file upload filters? Well, the only way to find out is to find out. So just proceeding on here, and I'll get into some of the other options that you can use with SQL map, but I just want to go through and get access to the underlying server. Let me see whether we have user share. Do we have? No, I want. We should have this under web shells. User share. We don't have it on this Kali Linux system. That's fine. I can always use my own Kali Linux system. This is probably where you want to do that as well. So let me just get out of full screen here. All right, and now on my own Kali Linux system, let me just what I wanted to do was let me open up a terminal, because I think I have the standard infamous PHP web shell. So cd user share web shells. There we are. We have PHP. Actually, hold on. Let's just go in here. Let's see whether I have it. So yeah, PHP reverse shell. So I can easily just I can easily just copy the contents of this. So, you know, let me actually do that. So I'm just going to actually just copy it. So copy PHP reverse shell, and I'll copy it to my desktop. And let me check that out. So there we are. We'll just call it shell.php. Actually, I don't know why I'm doing that. Move PHP to shell.php. All right, so let me just copy it, and you can again copy stuff to and from the attack box on CyberRanges, but save this on my desktop, shells, open, and yeah. So what we're going to be testing for now is fairly obvious. We're going to be testing for, we're going to see whether we can upload files again with any extension, in this case an executable extension, but so I'm just going to bring this in here. Actually, no, for some reason that did not. Let me see if I can paste that in there. There we are. So you can use Control-Shift-Alt because the lab environment gives you RDP access via Apache Guacamole. So you can, on your keyboard, when in the Kali Linux system provided to you, you can use the Control, Shift, and Alt keys to paste stuff into the keyboard. So Control, Shift, Alt, you can see that there. Just provides you with a convenient way of doing that. And there we are. So I pasted it. So we want to save this as desktop. I'll just say shell.php. And make sure I set that to all files here, and we'll not change the extension. Let's see if it actually works, but first I want to change the IP here. So we want to change this to the IP address of the Kali Linux system. So just going to zoom in this case, the IP of the Kali Linux system in the CyberRanges lab is 192.168.125. Let's see, I believe, actually, I can just check it out here. What am I doing? 0.200. So there we are. So 200, and we'll just listen on, with netcat on 1, 2, 3, 4. So I'll go ahead and save this here. And now we can go back to the web application. We'll just call it, test. And again, we're just testing things. So there we are, shell.php. Let me set up my netcat listener. NVLP 1, 2, 3, 4, the port. What's this category? Very interesting. So we can add it to a category. Let's add this. No PHP. All right. So not as lucky as I thought I was going to be. So we can probably try a few tricks. Let's try the most basic, right? Which is just, to see what type of filtering there is. Is it just the extension or file name filtering? Let me go to the desktop here. Let's change the name to shell dot, let's say p, and the common trick, as you know, php, like so, something like that. Let's try that out here. Let's try this. So, okay, new picture. We'll call this bypass. And let's go ahead and try this out. By the way, did I start up my netcat listener? Let me make sure I do that. Just don't want to miss anything. Let's add it. That worked. So if I now click on bypass, picture bypass. Okay, interesting. So I navigated to it. No, actually that was executed. So interesting. And there we are. So we have access to the underlying server. And I believe let's get a bash session. You can now perform your standard enumeration. I don't know whether we want to elevate our privileges, but do we have netstat installed? Let's get another session. I forgot no job control. Go ahead and reload this. There we go. All right. So yeah, we've pretty much got access to the underlying server. And now we can obviously try and navigate to the default directory used by Apache, var www.html. That's weird. cd var, where's that stored? Oh yeah, this is Debian. And there we are, no HTML, and there we are. So we have index.php, admin. Let's go into admin. Let's see what we have in here. Index, login, new.php. I want to see whether we can find the credentials or the configuration file. So we have admin, all.php, cat, classes, CSS, images, index. We don't have, it's probably in login most likely. Yeah, probably. So we'll just go into admin and we'll just say login.php. Where is the connection to the database? Classes db.php, my bad. So there we are, cd classes, there we go, and cat db.php. The reason I'm doing this is important. So MySQL localhost, Pentester lab, and Pentester lab. So user Pentester lab, password Pentester lab. So the reason I'm doing this is because we're now going to log in into this MySQL database to show you what essentially happens when you put in, for example, that single quote from a query perspective. So just give me a moment. All right, I just realized that there's no real way of elevating privs on the underlying server. Although I tried to log into the MySQL database again. I could if I spawned a shell or, used an SSH used SSH to connect, and that's probably something I can cover in a follow-up video. So I want to end this episode of Pentesting Diaries by covering some techniques that I use in identifying SQL injection vulnerabilities, not to do with the SQL map, which again I'll probably make follow-up videos on, because I know this is not that extensive, but one of the, again, as I mentioned, one of the techniques I use in automating or during my workflow when finding SQL injection vulnerabilities or testing web application inputs is obviously to take, you know, for example, you know, one of those lists of payloads, SQL injection payloads you see with, you know, provided to you by sec lists, etc. And actually, I don't know whether we have this user share on the Kali Linux system. So let's say word lists, user share. Do we have anything in here? What do we have in here? No word list. All right, so I'll actually show you what this would look like. So what I'll do is, let me just exit full screen. All right, there we are. So I will download my VPN certificate. And I believe what version? I think I'm running the latest version. So I'll now use my own Kali Linux system to show you. This is probably better. So I'll open up a terminal here on my Kali Linux system. So this is again on mine now. I'll go into downloads, and in here we have that. So I'll say sudo open VPN. And this is the great thing about CyberRange, is you can use whatever environment you're comfortable with to do whatever you want. So there we are. There we are. Okay, so that means now from my own Kali Linux system, I can say 192.168.125. What was the address of the target web server? 150, just to test it out. There we are. Works perfectly fine within my Kali system. So what I was referring to was automating the testing with, you know, a tool like Burp Suite. So, for example, I'll just open up Burp Suite, and again, using the community edition. Don't judge me. This is not my, you know, this is not the VM I use for my work, but what I use for HackerSploit. Hence the really cool wallpapers, by the way. And anyway, let's close this up here. Quite a few windows opened. Anyway, so we'll go into the proxy. I'll open up my browser, and I'll open up the Burp browser here just to keep things nice and simple. And I'm going to show you how I would test either, you know, a parameter within the URL, or a URL parameter, or anything included in an HTTP request, regardless as to whether, you know, it's a get or a post, whatever input you're testing. So, you know, I'll say 192.168.125. I've forgotten the IP again. 150. So let me go back in here. 150, and I know you may be a bit confused with me switching back and forth, but let me switch to test, and there we are. So I'm now going to intercept, and I'll reload this. Sorry, I'll reload this there, and you can see, let me increase the font size here. User interface, display, yeah, I think let's change this to 18. Actually, no, that's the interface size. My bad. I think what we want is this right over here. Where is the user interface, hotkeys, display, appearance, scaling? Where is this? I believe, hold on a second. Am I getting confused for nothing here? There should be a way to modify the HTTP, the requests tab, table appearance, scaling. Wait a minute, it's appearance, user interface. Yeah, so I'm pretty sure this option was somewhere here. Hold on a moment. Proxy settings. No, it's not there. I can't believe I've forgotten where this is, because I never usually modify, because this was somewhere here. So proxy, proxy settings, yeah, it should be in here. Proxy, let me see, why is my burp suite slow today? Inspector, yeah, it should be somewhere here. There we are. It was just my fault, did not see it, but there we go. So what I can actually do is send this to the repeater, which, you know, we already know we can use it for manual testing. So for example, let me send that. We get the response, and then of course, you know, I can render it, and we can then test the single quote here. So to throw an error for error-based SQL injection, nothing too crazy. But if I go back into the proxy here, let me go into the proxy, and I send this into the intruder, which we can use for fuzzing. I can specify this right over here as the payload. So I can add this as a position. So there we go, right over there, if we so choose, you know, and, you know, we'll have that inserted there. Let me just clear this out. So we can just say 1, and as you know, we can just highlight the value there. Obviously, this is much simpler, so I can add that as a position. We'll use sniper. For the payloads, this is where you can now load the, if I go to user share, and I go into sec lists. So I'm pretty sure you're familiar with sec lists, but we have in here fuzzing. Under fuzzing, you have your SQL injection fuzzing lists, which essentially contain payloads. So for example, that you can use to inject into any application input to test for various, you know, types of SQL injection vulnerabilities. So, you know, I can start the attack, and then obviously you're going to be monitoring the response. So if we take a look at this one here, you can view the response. Let me render. There we are. So in this case, error-based SQL injection, or through an error here, another error. In this case, we don't get an error, but it looks like this was time-based. So we can actually, if we take a look at the request here, you can actually monitor the performance, which I'll not do. Let's go to the next one here. So another, so pretty much this is how I test for SQL injection automatically using different payloads, or the payloads that I've been, I've not been talking too well about them, but you know, the ones on GitHub or the ones in SecList, you can easily use a tool like Burp Suite to test for specific application inputs, whether it be, you know, in the URL, etc. You can just, you know, set the parameter or the value of the parameter as the position for the payload, and then Burp Suite will do it for you. And yeah, so we're pretty much getting or confirming that the web application is vulnerable. And that's what you want to do as a web app pen tester or bug bounty hunter, is you're just testing to confirm, you know, POC pretty much. You're not doing anything malicious here. In any case, let me pause that there, and let me terminate that. I want to discard that, and there you go. So that's one tip. Obviously, I know this video has gone on for long enough. So thank you very much for watching. Do check out CyberRangers if you want to, again, go through this particular lab. I'll post a link to the CyberRangers platform, as well as a link to this particular lab, which is SQL injection to shell, which, as I mentioned, can be found under the community section, which are just free labs. Yeah, so you'll find that in the description section of the video. There's other labs you can go through. As I said, I'll be publishing others, again, in the free section, and others, you know, on the CyberRangers platform. But yeah, there's a lot that you can check out. This was just, you know, video to kick off this series and to get things going. Hopefully you enjoyed this series and the new format. As I said, I'll be making improvements to the video format and the, you know, the transitions or the sections, and obviously illustrations to make, to essentially aid your understanding of what's going on. But yeah, hopefully you enjoyed this video, found value in it. If you did, please leave a like down below. I would like to hear what you think about the new video format, any suggestions for other episodes. As I said, I'll probably have a follow-up episode tomorrow. or 24 hours after publishing this video on, SQL, although I don't think that'll be too popular. There's a lot of exciting stuff that's coming up. Anyway, hope you found value in this video, and if you enjoyed the video, leave a like. Would love to hear what you have to say, and yeah, great to be back, and I'll be seeing you in the next video.